Now it's time to outline the backpropagation algorithm itself. I'm not going to derive this from first principles because there are plenty of derivations of it on the web and on YouTube. I'll just show you how to apply it. To make this simpler, let's just consider a small part of a network as shown on the screen. Here we have part of a network with 3 neurons A, B and C and 2 weights. WAB connects neurons A and B and WAC connects neurons A and C together. We start the algorithm by setting all the weights in our network to random numbers. Often these are between -1 and +1. Next, apply the first input pattern that you'd like to train to the network and calculate the output. In other words, perform a forward pass. Now for each output neuron, we know the required output value, in other words a target, for each pattern. And so we can calculate an error value, which is what you want minus what you get. That is the output value from the forward pass minus the target. The exact formula for this is shown on the screen for neuron B. The first part of this formula, output B times 1 minus output B, corresponds to the derivative of the sigmoid function, and this changes if we use other different types of activation or squashing functions. For example, for a simple threshold unit, it's only target minus output that's required. So next, having calculated all the errors for this particular layer of neurons, we update each weight in the layer. The new weight is the old weight plus the error of the neuron at the end of the weight times the output of a neuron feeding into this weight. I'll designate the updated weight with a plus superscript. The formula for weight AB is shown on the screen. Note that if this neuron was connected to an input, then instead of output A, we would have input A. Note that the output value used is from the feeding neuron, neuron A, and not the fed neuron, neuron B. This is a common error when writing the algorithm. Now we go through the entire layer, updating all the weights. And we need to do the same for the other layers of the network. But we run into a problem if we try and apply the same algorithm to the next layer down. And that problem is that there are no targets. We only have targets for the output neurons. The solution to this problem is why the algorithm is called backpropagation. We backpropagate the error from the output neurons to give a new error for the inner layers. This is done by taking the error of each neuron connected to the one of interest and feeding back its error through the connecting weight. These weighted errors are then summed to produce a new error for the hidden neuron. So in the case of our example network, to produce an error for neuron A, we feed back the errors from neurons B and C through their connecting weights to A. The formula for this is shown on the screen. Again, the factor output times 1 minus output is present because of the sigmoid squashing function. Having obtained this error, we can proceed exactly as we did previously and update all the weights in this layer. Once we have changed all the weights in the whole network once, and only once, we apply the second pattern to the network input and repeat the procedure, again once only for this pattern, and then the third pattern, and so on. The general algorithm for this is shown on the screen for the first 4 letters of the alphabet. We keep doing this until the sum of all the errors for each pattern is acceptable. The formula for this is shown on the screen. Note that because some errors are negative, we must make all the errors positive before we add them all up. We'll see later what acceptable means, but for now, we can just stop the learning algorithm when the total error falls below a suitable value, say 0.1. The flowchart for this is shown on the screen. Once we have trained the whole network and the total error is acceptable, then we can use it to recognize any of the patterns that we trained it with simply by performing a forward pass. And this is how the network is used when we actually want to recognize a pattern. The training algorithm is only used to initially teach it. All the calculations for a single training step for one pattern in a simple network are shown on the screen as a summary. In the next few videos, we'll delve into improvements into the algorithm and look further at how it works.